Good evening, Doc Jen. Good evening, classmates. The topic that I'm going to discuss this evening is about ethers and peroxides. Our objectives: first, compare ethers and peroxides based on their properties. Second, give the common and IUPAC name of ethers and epoxides. And third, draw the structure of ethers and epoxides. Ethers are dialkyl derivatives of water. R bind by O, bind by R prime. They are also derivatives of alkoxy, of alkenes. The functional group is ROR prime. The general formula is CnH2n plus 2O. The physical properties of ethers are as follows. The lower ethers are highly volatile and inflammable. They are considered as good organic solvent. Simple ethers like diethyl are tasteless, but take note, they are having specific smell. Lower ethers also act as anesthetics. It is usually observed in a hospital in treating a particular wound. They are slightly polar. Ethers form hydrogen bonding with water. It has a low density than water. Ethers have lower solubility in water as compared to alcohol. Increasing order of solubility. Alkanes is less soluble compared to ethers, and ethers is less soluble compared to alcohol. So meaning alcohol are highly soluble to water as compared to ethers or compared to alkenes. So mostly alkenes are insoluble in water because they do not form hydrogen bonding of water. Ethers also have lower melting and boiling point than alcohol, but higher than alkenes. There are two common ways to name an ethers. First, using the IUPAC name, which we were using in naming other organic compounds. And the second one is by giving the common name. In using the IUPAC name, let's try to find out the longest carbon chain, and that will be considered as the parent chain. The alkoxy groups with a shorter carbon chain is considered as the substituents. Then the substituents attached to the longest chain are placed at alphabetically or be named in alphabetical order. For example, in this number 1 example, we have here on the left side 1 carbon. We can give its first name as met, then as last name N. Taking into consideration, it has only a single bond. And on the right side, we have the substituents. The carbon is being attached to oxygen. So again, we have only 1 carbon. So we can give the first name as met, but the last name will become OXY, taking into consideration that it is attached in carbon. So the IUPAC name of this molecule will become methoxymethane. And for its common name, just simply name all the substituents attached, then write ether on its last name. And since in this example we have 2 carbon, act as a substituents, so we can name it as dimethyl. Just change the N to YL, then write the word ether. For our second example, let's try to find out the longest chain. And it is here on the right side. We have 2 carbons. To give its first name, it becomes eth. And the last name will be N, since again it has only a single band. And on its left side, we have the substituents. And since again it has only 1 carbon, we can just write the first name as meth and write OXC as the last name because it is being attached to oxygen. So we can name it based on IUPAC rules as 1-methoxy or just methoxy 18. For its common name, we will just name all the substituents attached to oxygen. So on its left side, we have 1-meth. On its right side, we have eth because it has 2 carbon. And just write YL as their last name and arrange alphabetically. Since 8 comes first than meth, so the common name will be ethyl methyl ether. For the third example, again, let's try to find out the longest chain. And we have here 1, 2, 3. 3 carbon. So we can give the first name as prop. And N as the last name because it is single banded. And for its substituents, we have on its left side, we have again 1 carbon. So we can name it as meth. Then change the last name into OXY because it is attached by oxygen. So to give its IUPAC name, we can just simply say 1-methoxy or methoxypropane. And for its common name, we will again name all the substituents. So we have here meth, then change the OXY by YL. Then on the right side, we have the prop, then change again the N to YL, then write the word ether. It becomes now methyl propyl ether in writing it based on alphabetical order. For the next example, again, let's try to take a look. Where is the long chain? So we have here is 1. So we have how many carbons? 1, 2, 3, 4, 5, 6, 7. So we can give the first name as hept. Then again, it is single banded. So give the last name as N. And let's try to find out where is the substituents is located. So it is here. So we need to assign the substituents the lowest number as much as possible. So in numbering, we will start from right to left. So this will be the number 1, number 2, number 3, number 4, number 5, number 6, and number 7. Since the substituents is being attached in the 3rd carbon, and it has only 2 carbons, joining the oxygen, so we can name it as eth and change the N to OXY due to the presence of oxygen. So the IUPAC name now will become 3-ethoxyheptane. When ether is part of a larger molecule, we will still follow the same rules for naming organic compound. In this example, we will start identifying the parent chain. So this is the parent chain. And numbering from the side that given the ether the lowest number. So in this case, this will be the number 1, number 2, number 3, and number 4. Since we have 4 carbons as parent chain, we can give the first name as but. Then, its last name as N due to the fact that is single bonded. And for its substituents, it is located in the second carbon. So, having 2 carbons together with the O substituents, so we can name it 2eth. Then just add OXY as a last name because it is being attached by the oxygen. Then the IUPAC name for this will be 2-ethoxybutane. If given an ether with a cyclic substituents, we will still follow the same rules. First, we will identify the longest chain. And in this example, this is the longest chain. We have 1, 2, 3, 4, 5, 6 carbon. So we can give the first name as hex and the last name as N. And since it has a ring, we can give the prefix name as cyclo. So the parent chain is called as cyclohexane. And for the O substituents, since the carbon here has 1, 2, 3, 4, 5, we can give the name as pent. Then the last name as oxy, coming from the oxygen substituents. Then again, it forms a ring, so we can give the prefix cyclo. So the IUPAC name for this structure will be cyclopentoxycyclohexane. Drawing the structure of ethers. Let's try in this example 1-ethoxyethane. To draw the structure of this molecule, let's try to find out first what is the longest chain. So we have the ethane. So ethane stands for 2 carbons. Okay, so this is now our parent chain. So for our O substituents, we have 1-ethoxy. So eth means 2 carbons. So we have another 2 carbons attached to oxygen that becomes ethoxy. So this is our parent chain, the ethane. I'm sorry for my handwriting here. Then this is our 1-ethoxy. 1 because it is being attached in the first carbon attaching the oxygen. So the name of this molecule is 1-ethoxyethane, or just simply say ethoxyethane. In this example, let's try to draw 1-methoxycyclohexane. We need to identify first the parent chain. So we have here the hexane. So when you see hexane, it has 6 carbons. And since it has a prefix of cyclo, so it forms a ring. And for its oxygen substituents, we have 1-methoxy. So we have only 1 carbon attached to the first locant. So the drawing will be like this. So we have 1, 2, 3, 4, 5, and 6. So this is now our parent chain, the cyclohexane. So the O substituents is here in the first locant. So here the O, where the meth is being attached. So this is now what we called 1-methoxycyclohexane. So let's try to name this structure. So again, it has the longest parent chain, which has 1, 2, 3, 4, 5 carbon. So since it has 5 carbon, the first name is pent. Then it is bonded by a single band, so the last name is N. And as we see in this structure, there are two substituents, first and the second. And it has 2 carbon attached to oxygen substituents on both sides. So we can give the first name of eth, then give the last name of oxy because it is attached to oxygen. And since there are 2 substituents, we can use the prefix di. And the 1 and 5 here is the locant. So in the first substituents, it is attached to the first carbon. So that is why it is 1. Then here, the second substituents, it is attached on carbon 5. So the name of this structure will be 1,5-di-ethoxypentane. The physical properties of epoxides. Epoxides contains an oxygen atom attached to 2 adjacent carbon atoms of a hydrogen. So C is bound to C and both 2 carbons are bounded to O. The strain of the 3-membered rings make an epoxide much more reactive than a typical cyclic ether. They are similar to analogous ether. It has a low molecular weight. It is colorless, non-polar, and often volatile. There are 2 ways to name epoxides, both of which were tackled in naming an organic compound. The first one is to use the prefix epoxy following the IUPAC rule in naming, and the second one is to use the suffix oxygen at the end of the molecule. So in this example, we have here oxygen attached to 2 carbons. So this is the first carbon and the second carbon. So to give the name for this molecule, since we have 2 carbon, this is carbon 1 and this is carbon 2. So we will give the first name as eth and the last name as N because it has only single band. And since the O is attached to the first and the second carbon, so we'll give the name as 1,2 as the prefix name epoxy, ethene. Now let's look at the substituted epoxide. For the IUPAC rules, we will still identify and highlight the parent chain. So in this case, this is the parent chain. And let's do the numbering so that the epoxides gets the lowest number. So we can start from the right. So this is number 1. And this is number 2. Having a total of 3 carbon in the parent chain, number 3, we're going to give the first name of group and the last name of N because it is single bonded. Then, since O is bound to 1 and 2, giving the name as 1 and 2 with prefix epoxy propane. So this is now the IUPAC name. Using the oxyrin method, we need to identify the entire epoxides as a parent chain and simply call it as oxyrin. Since we have a methyl substituents, here we simply threw the word methyl in front of the oxyrin. Since we only have one option to connect the methyl to one and the other carbon, we don't have to specify which one and give a final name of methyl oxyrin. In this example, we still need to identify the parent chain. So this is the parent chain. But if we're going to number from left to the right, 1, this will be 1, 2, 3, 4. The epoxide is attached to number 2 carbon. But if we're going to number from right to left, so 1, 2, 3, 4, still the epoxide is being attached to carbon 2. But since there is ethyl group here, we need to do the numbering from right to left. So this will be number 1, 2, 3, and 4. So to give the name of this structure, since there are 4 carbon, the first name will be but, and it has single bond, the last name will be N. For the epoxide, since the O is attached at carbon 2 and 3, so we'll give the name to 3 epoxy using its prefix. And we have here methyl attached to carbon 2, so we can give 2 methyl. And since epoxy or E comes before M or the meth, so we give this structure the name of 2,3-epoxy 3-methyl-butane. In using the oxyrin method, in this case we have multiple substituents. We have the methyl and the peroxides. So we have to give a unique numbering on this system where the O gets the number 1 and number 2. This is more to be substituted or higher substituted of C of the oxyrin. And the carbon 3 is the second C. In the ring. In this case, we have 3 methyl group. 2 coming from carbon 2 and 1 coming from carbon 3. So that gives the name of 2,2,3 trimethyl because we have here 2 methyl or 2 methane. Then we have another here, the methane, and change the N to YL, so it becomes 2,2,3 trimethylhexane. When our peroxide show up on a ring, just like this, we need to treat it the same way. In this case, the parent chain has 6 carbon. So we give the first name as hex and the last name as N because it is a single band. And since it form a ring, so we give the prefix cyclo. When numbering, we make sure that both the C here should be in sequential number. We can choose either clockwise or counterclockwise. So in this case, the epoxide show up carbon 1 here, carbon 2, 3, 4, 5, and 6. The epoxide show up on C1 and 2, giving us 1,2 epoxy. So this is the epoxy substitute. However, since there are no other substituents here, the numbers are understood and there's no need for us to include them. So this gives the final name of epoxy cyclo. Good. Let's try to do the structure of this peroxide. So we have here 1,2 epoxy ethane. So since our longest carbon chain is ethane, so it has only 2 carbons. So if this is the O, we have 1, this is 1, the first carbon. Sorry. Should be straight. Oh my god, I'm sorry. See, taking into consideration this is a straight line. So this is the first carbon, then the second carbon. So this is the O, the epoxide is being attached to carbon 1 and carbon 2. So that is why it is named as 1,2 epoxy ethane. Okay, in this molecule, we have here the longest parent chain, the propane. So when we see propane, it has 3 carbons attached to the substituents epoxide. So if this is the O, we have first carbon. This is a first. Okay, this can be the first carbon, the second carbon attached to O, and we have here another carbon, which is the carbon 3. So, since we have 3 carbons, so it is the prop and single bond, that is the N. And the first carbon is and second carbon is being attached to the epoxide substituent. So that is why it is called 1,2-epoxy propane. Okay, thank you so much for listening, and God bless.